Hi, Algebra students. These are your notes for Chapter 1, Section 2. So today we're going to work on solving linear equations using two steps. So yesterday you might remember we solved equations with simple one steps, like either just add, subtract, multiply, or divide. Today these equations have two steps. So if you look at example A, you can see the two steps here are multiplication and subtraction. So in order to isolate x, when I undo my operations, I'm always going to start with my constant first. So if I'm subtracting 13, my inverse operation is to add 13 to both sides. So add it here and here. And when we simplify that, the 2.5x drops down. 13 and 2 gives me 15. Because I'm multiplying here, my inverse operation is to divide both sides by 15. Okay, so divide by 2.5 here, divide by 2.5 here, and 15 divided by 2.5 is 6, so that's my final answer. One thing we didn't talk about yesterday is checking your equation, so just remember you can always do a quick check by taking the value you found for x, and then you would just plug it in up here and make sure that 2.5 times 6 minus 13 is equal to 2, so you know you did your work correctly. Let's move on to number 2, or example B. In this one, what you'll notice is you might have to do a little bit of simplifying before we can solve. Okay, so maybe make a note up here. Simplify before you solve. So in this equation on the right-hand side, I have some like terms that I can combine. 9x and 6x can combine, and that gives me a sum of 3x, or a difference of 3x. And everything else is going to drop down. Now that I've simplified my equation, you can see that it is a simple two-step equation. I'm going to undo the constant by subtracting 15 on both sides. Now, pay attention to your integer rules. Over here, 12 is negative and 15 is negative. So you add those together and keep the sign. So that's negative 27 is equal to 3x. To isolate my variable, I'm going to divide both sides by 3. Again, using integer rules, a negative divided by a positive gives me a negative, and 27 divided by 3 is 9. So there's my final answer. Looking at example C, this one's a little bit different. You do have two operations, so addition, and then this large fraction bar here means we're dividing. And when you see a fraction bar like that with an addition or subtraction sign in the numerator, that fraction bar is going to function as a grouping symbol. So what it does is it kind of groups this whole term together. So that entire term is being divided by 3. So your order of operations work a little different here. So instead of subtracting first, we actually have to multiply by 3 on both sides first in order to clear this fraction. So this cancels and we end up with q plus negative 5, and over here, sorry, I wrote this wrong. We're actually multiplying the 8 times 3, which is 24. Okay, so down again, back to that simple one-step equation. So even though this is an addition equation, 5 is negative. So instead, I'm going to add a positive 5 to this. Think about making a 0 pair. So that's what I'm doing here. Is I really want these 5s to cancel and 0 out. So that leaves me with Q, and then 24 plus 5 is 29. So that's my final answer. Example D, we have division and subtraction. So again, I'm going to undo the subtraction of 5 by adding 5 on both sides. The F over 4 drops down. Negative 9 plus 5 is negative 4. Okay, to undo division, we multiply by 4 on both sides. We show that with parentheses. Out to the side, these will cancel. Final answer, negative 16. Okay, so F equals negative 16. All right, I'm going to go ahead and move on. So let's take a look at this next section. Sorry about that. Okay, so this time notice we have the same exact equation, but we're going to show two different ways to solve it because of the set of parentheses. So in the first one, method one asks you to solve it by using the distributive property first. So what we could do here is distribute this 2 to those numbers inside parentheses and simplify this. Again, simplifying before we solve. 4 plus 1, 7. And then we can combine these like terms. So negative 4 plus 1 is negative 3. And then using the inverse operation, we would add both sides. So 2x is equal to 10. Then we would divide both sides by 2. So x equals 5. Okay, quick reminder, you can pause the video at any time. If I'm going too fast, just pause, slow down, and allow yourself time to catch up with me. Okay, so let's go to this next equation. Method 2 is to divide. Okay, this is not my favorite method. I think it's actually a little tricky, but we'll go ahead and do it anyway. In order to use division, you still have to isolate this entire term that contains the variable. So that means I still need to subtract 1 from both sides first to isolate that. So now I have 2 times x minus 2 is equal to 6. Now, instead of distributing the 2, since 2 is being multiplied by this entire expression, I can divide both sides by 2. So the 2's are going to cancel over here, leaving me with x minus 2. 6 divided by 2 is 3. There we go. And then simple one-step equation, add 2 to both sides, and x equals 5. Okay, so you'll notice we got the same exact answer, just a little bit different strategy. And again, you of course would decide which one makes the most sense to you. Okay, you can either try these 3, A, B, and C underneath, or we'll of course go over those in class together. And I'd like you to go ahead and turn to the next page, and we're going to look at one more problem together. Okay, so this time I want you to take that knowledge. We're going to apply what we've learned to this geometry application problem. So I know this part up here looks like 2 problems, but this actually all goes together. So it says the sum of the interior angles of a polygon can be found using this formula. S meaning the sum of the angles is equal to 180 times n minus 2. And this should look really familiar to you from last year. Okay, I know you did some problems like this, but we're going to revisit it. So the first thing we're going to do is come up with an equation. All right, so the first thing you have to do is figure out what should the sum of all these angle measures be. So remember, n is the number of sides. So this is a 1, 2, 3, 4, 5-sided figure. So the first thing I'm going to do is plug in 5 and place n and figure out the answer. So 5 minus 2 is 3. So it's 180 times 3, which is 540. That means the sum of my angle measures for this entire figure should be 540. So remember, I'm going to go ahead and take all of these angle measures and I'm going to set them equal to the 540. Now, there is not enough room on, well, I guess if we simplify within, we can. So let's do that. Let's first combine all of our like terms, okay? So we have all of these x's we can put together. So we have, let's see, 5, 10, 18, 21, 25. So we have 25 x's. And then if we add all of our constants together, which are these here, so 5 and 2 is 7, and 8 is 15, plus 10 is 25, and that would give me 40. I sure hope my mental math is correct. Hold on. All right, and we'll set that equal to 540. Sorry about that. Equals 540. Okay, so our next step would be to just solve for x. So we would subtract 40 from both sides. So that means 25x. I'm going to finish it under here. Not really enough room for me to work. Is equal to 500. So that means x is equal to 2. Okay, and remember, you can check that by plugging 2 in place of x in all of these angle measures and adding it up. Okay, so if I just checked my answer, I realize it's not 2. My correct answer, sorry that keeps happening, is 20. I forgot my 0 on the end there. So let's make sure we fill that in, and it should say 20. I'm sorry, this keeps messing up. There we go. It does not like me. All right, we're going to finish up there today. I apologize for the glitches. I am going to try to get those worked out and using a different way to record the videos, but we're going to use this one for today. So good luck with your assignment. I think this is enough instruction and we'll follow up on some problems in class.